Good morning, everyone. So we are really happy and we thank you for joining us today for an exciting and insightful webinar this bright morning. So the topic for our webinar would be ArcGIS Reality for Photogrammetry. My name is Aryan Sharma and I'm thrilled to guide you through this session where we will explore the cutting edge capabilities of ArcGIS and that too in the realm of photogrammetry. As many of you know, photogrammetry is the science of making measurements from photographs. With advancements in technology, this field has seen tremendous growth and integration from photographs into various fields and applications from mapping and surveying to urban planning and environmental monitoring. Today, we'll dive deep into how ArcGIS Reality is revolutionizing photogrammetry by providing powerful tools for capturing, processing, and further analysis of the spatial data with unprecedented accuracy and efficiency. So during this webinar, we will cover the following key topics. I will be giving you an overview and further understanding of the core features and functionalities that make ArcGIS Reality a leader in geospatial technology. Then I will also be covering reality mapping with ArcGIS Reality, which provides a complete workflow of how ArcGIS provides end-to-end workflow to process various datasets. Then, what are the outputs we can generate, be it a 2D or 3D, we get true orthos, meshes. We will talk about that in the further slides. And after coming on to the reality product umbrella, what different products do we offer? I'll also be demonstrating key photogrammetric processes from image ingestion to the final output. In the end, I'll give you some real world examples showcasing the diverse applications of ArcGIS Reality in various industries. Additionally, in the end, there will be a Q&A session. So please submit your questions in the chat throughout the webinar. So whether you are a seasoned GIS professional, a photogrammetry enthusiast, or someone new to this field, I believe this webinar will provide you with valuable knowledge and practical skills to enhance your projects and workflow. So let's not waste time and dive into the transformative power of ArcGIS Reality for photogrammetry. ArcGIS provides a comprehensive imagery system for the capabilities of imagery. So we divide the system into these pillars, which are one topic of their own. So ArcGIS as a system, it allows us to create reality mapping using drone, aerial, and satellite imagery. After that, using the data inputs, we can generate true orthos, meshes, point clouds as a product. We will be talking about this in further detail in the upcoming slides. On the bottom, it helps us in data management using data models that are optimized for different types of imagery. On the right, it also allows you to leverage your imagery through visualization. This is basically exploitation of content. How can you visualize? What can you do with it? More or less, it allows almost all type of data, from data cubes and voxels to oriental imagery and videos. Then the analysis side includes image classification, change detection, and other Geo AI processes, including extracting features, footprints, etc. Today, I'll be talking about reality mapping in detail. So, what is reality mapping? So, we define reality mapping as the process of creating accurate digital representation and of the physical world using images, LiDAR, or both. So, reality mapping is about bringing reality capture and GIS together with an emphasis on geospatial accuracy. More important than what it is why it matters. Why is it important? At Esri, we help people transform the world by unlocking the full potential of location intelligence to solve problems. As a part of this effort to better understand our natural and built environment, we believe that an accurate and up-to-date digital representation of this world is critical to making informed decisions, be it in business, in government, or in science. Reality mapping at first allows us to create or update generational foundational content through highly automated processing. Using imagery from drones, airplanes, or satellites, we can create 2D products such as true ortho, multispectral orthomosaics, and elevation models. Videos can also become geospatial data products if and when they are associated with the right orientation data. 3D products like point cloud or mesh have also become an essential part of what helps us understand our world. So, what is the guarantee of relative accuracy that what we have created is on the right location, or when will be knowing that if we extract a feature from an imagery, it will be there in the real world? This content is highly accurate, down to the pixel, and also its analysis ready for workflows such as feature extraction and change detection. Last but not the least, here we use the advancement of photogrammetry, the big magic, being able to create a 3D representation for each pixel from at least two images. The 3D data products allow you to build a photorealistic GIS experience, which can serve as a foundation for the creation of digital twins. Reality mapping empowers GIS professionals like us to create an intuitive 3D GIS that even non-specialists can really easily relate to, enabling our engage with the geospatial data in the real world context. So in reality, we basically follow this workflow. On the left, we have ArcGIS Reality, which supports variety of imagery captured from drones, crewed aerial aircrafts, or satellite using satellites with RGB sensors, as well as thermal, multispectral, and soon LiDAR. It processes this data to generate 2D products such as true orthos, digital elevation, as well as 3D mesh and 3D point clouds. We can also manage a set of individual images or videos in geospatial context throughout oriented imagery catalogs. And the last part on the right is analyzing and sharing. The good thing is all these data products, they can be seamlessly fed into GIS and BIM to perform a variety of analysis tasks, be it from inspection to feature extraction. So basically, what ArcGIS does is more than just reality mapping. It provides us complete imagery solutions integrated in its own ecosystem. From gathering your data, then processing it in the ArcGIS Reality family, to making it part of the ArcGIS system. And then comes the imagery management part, which uses Image Analyst, Image Online, and Image Server for analysis and visualization purposes. And then at last, using other parts of ArcGIS system to derive further insights, integrate imagery with other content, and then collaborate. Having introduced you to the transformative capabilities of ArcGIS Reality for photogrammetry, let's now explore the high quality outputs it can generate, which are invaluable for applications like urban planning, construction, and environmental monitoring. So again, let's not waste much time and delve into these outputs and their real world significance. Now let's take closer look at output you get from ArcGIS Reality. So what is it that we want and what is it that we are getting? First, there are true orthos on the left, which provide a pixel accurate imagery layer. This means In each pixel, the image is spatially consistent with mapping data and elevation. True orthos, the good thing about true orthos is that they are also very consistent among multiple flights. We can use them to perform precise measurements, and then after that, apply change detection and deep learning algorithms. Second, ArcGIS Reality lets you create an accurate digital elevation model. This can be used for topographic surveys and hydrological analysis. And in 3D, we can create point clouds to provide highly accurate representation of reality. They can be used for precise 3D point measurements and point cloud classifications. And you can also generate a mesh as a photorealistic carrier format for your geodata. So basically, it's an intuitive way to empower our non-specialist friends to interact with our data. And then it lets you integrate your existing metadata. So you can fully generate a 3D mesh for site or a citywide or a countrywide mapping, as well as a mesh, which is more suited for the countrywide scale. So to illustrate what some of these outputs bring to the table, let's start by taking a look at what a traditional orthomosaic image looks like. In this case, the image is based out of a satellite imagery of Boston. Notice how you see a lot of leaning buildings if it isn't the Leaning Tower of Pisa. That isn't ideal if you want to use the imagery for analysis. Here, you notice the same area, but this time it is represented using a true ortho generated from ArcGIS Reality. Actually, it virtually eliminates all the building lean, and that's just for the start. Now every pixel in the image appears as though it was captured directly overhead from another position. So when I get back to the input satellite orthomosaic, this highlights the removal of building lean with true ortho, further making it ideal and accurate for other feature extraction and overlaying content. And also you can even create true orthos using drone imagery. Here's an example that was created from 1 centimeter imagery, and it was captured using a free-fly Astro drone. Now coming on to DSM-based true ortho. With true orthos, every pixel appears in its geometrically correct position. These aren't spatial, there are no spatial distortions like object leans that we just saw, or seam lines. But instead, every object is shown from same top-down again another perspective. This makes true orthos the ideal 2D product for accurate feature extraction, change detection, and as we talked about, other automated analysis workflows. But what about 3D? Just take a look at this high resolution aerial image of Boston. Now, do you see any difference? But yes, it is different because now look at this 3D mesh and it was just created using ArcGIS Reality Engine. It is fully 3D, but the photorealistic quality is nearly indistinguishable from the original image, right? So there are actually some enhancements to 3D mesh that you might have missed. Looking back at the original image, there are few details that jump out. First, we see a lot of vehicles in the image. If we want to create an accurate 3D data of our roadways, these vehicles actually get in our way. So we also in the bottom left corner, we also see some sun glint reflecting off the water toward the bottom right of the image. And some areas are obscured by the shadow cover. So This is the 3D mesh, and if we flip back to the 3D mesh, many of the vehicles and other moving objects are gone. Now you can just see the more of the roadway underneath. Reflections of the sun glint have also been removed, and the visibility has also been improved in the shadow areas. So things to note in these two slides is that the photorealism of 3D mesh is similar to the high resolution input image. Moving objects in this input image and the vehicles have been removed from the mesh. Reflection, which was seen in the bottom left, has also been removed from surfaces, and areas with dark shadow have been enhanced. So 3D mesh. Let's talk a little about 3D mesh. 3D mesh is a high quality photorealistic 3D product that's invaluable to reality mapping and digital twins because it provides a photorealistic view. It gives users and geospatial enthusiasts an intuitive way to react and interact with their data. It captures our data in geometrically accurate 3D, optimized for rapid streaming at all levels of details. Comparing 3D mesh with point cloud, we would say we also support point cloud very well. While they don't provide the photorealism of a mesh, these are also very highly accurate 3D data sets, and many of our 3D analysis tools are designed to work with this point cloud data. So they are an important output if you're interested in running analytics on your reality mapping content. So let's dive further into the world of 3D mesh, and I'll be demonstrating some of the outputs of 3D mesh. This is a 3D mesh created in ArcGIS Reality of the Boston city. Let's take a closer look at this hosted web scene layer. This is Fenway Park, which is the home of Red Sox in Boston, home of the Boston baseball team. And the same, we have this mesh created from the corresponding to ortho image. Then we see Massachusetts State Museum. Here we cannot distinguish between the nearby buildings because we don't have the 3D content. But don't worry. When we get onto the 3D mesh of the State Museum, see how clearly this has been generated and how easily can we distinguish between the museum and the other building. We also have this true ortho of downtown. Here also every building from top will look kind of the same to you. But when I get to the 3D mesh, we will see that there is an elevation difference and many other differences which we can not make out from the true ortho. So now, having explored the diverse and powerful outputs that ArcGIS Reality can generate, we now turn our attention to the suite of tools and products that make these capabilities possible. What do we offer? What we are offering in the realm of photogrammetry. So ArcGIS Reality product family, it encompasses a range of specialized applications which are designed to streamline the photogrammetric workflows. It also helps us to enhance the data accuracy and other robust analytic capabilities. So let's delve deep into the key components of this family because we are kind of running short on time. So how can you access ArcGIS Reality and start taking advantage of what is reality mapping? ArcGIS Reality product family, it offers different experiences enabling reality mapping at any scale. or you can enable reality mapping at any scale or any extent. And the thing to be noticed here is all these products are powered by a single unified processing engine, that is the ArcGIS Reality engine. Some of you might be familiar with older Esri products like Drone to Map and SiteScan, but two newer products have been added to the family. And these different experiences are designed for different use cases. We'll be talking about them in further slides. So if you need to do the site mapping using drone imagery, or you can use our standalone desktop app, that is ArcGIS Drone to Map, or you can use our SaaS offering, that is SiteScan for ArcGIS. Both are designed to work with a mobile flight planning app to help you plan and conduct your flights. If you need to do the reality mapping at a city or countrywide scale, you can use ArcGIS Reality for ArcGIS Pro, which is an extension of ArcGIS Pro, or a standalone desktop app again, which is the ArcGIS Reality Studio. So this is just a different perspective to the previous slide that we just saw. How do we know which experience is best for you? Someone here might be working on a small scale, and someone might be responsible for the whole countrywide mapping and scale. So how do you know which is best for you? It all depends on the platform that you are using to collect data and the size of your project area. Drone to Map and SiteScan are solutions focused on drone mapping for sites with relatively small extent. You can use Drone to Map when you have small drone team, and SiteScan is a SaaS product designed to support comparatively larger drone programs, conducting a lot of flights. As the scale increases, so does the product range of reality. On the opposite end of the spectrum, we have ArcGIS Reality Studio, a hyper-focused application designed for the imagery which is collected by the crude overcraft over large area using metric frame cameras. It's great for citywide and country mapping. And ArcGIS Reality for ArcGIS Pro provides 3D reality mapping directly within ArcGIS Pro. It is designed for users that are working on large scale using a variety of sensors. So let's talk about these products a little bit in detail. Here we have ArcGIS Flight, which is the app which supporting reality mapping, a drone data capture application for further leveraging GIS. It is basically used to collect imagery and geospatial videos for use throughout ArcGIS system. It works offline by downloading base maps for local use. So you can plan your flight using your authoritative GIS content. If you don't have the internet connection, you can decide the area and then download the base map. So flights can be executed entirely autonomously using the app, giving you the repeatable and customizable flight plans for more consistent reality mapping. And also, you can process the imagery you collect using ArcGIS Reality, including by uploading the imagery directly to the SiteScan cloud. Moving on to the standalone drone reality mapping application. We have this application which is focused on reality mapping using drone map imagery again. It supports the ArcGIS Reality engine to create true orthos, point clouds, and 3D meshes. If you wish to work without internet on a desktop, this is the app for you. It supports rapid offline processing, and it is the perfect solution when you are on field with your laptop and you want to have a quick look at the result. It also supports multispectral calibration and has this vast processing capabilities, even with additional thermal infrared support. It is designed for images up to 75 megapixel and projects up to 300 gigapixels. That is too much that statement doesn't justify the size and this capability. So despite being a standalone desktop application, once it gets connected to internet, you can easily publish the data to ArcGIS Online and Enterprise. So coming on to SiteScan, next is SiteScan for ArcGIS. As a cloud-based drone imagery processing, it provides a complete end-to-end drone mapping software from drone flight planning, capturing pre-flight checklist, fleet management, processing and analytics, and whatnot. Because the data is in the cloud, it is a lot more scalable and there is no necessity to publish the data. It can be immediately accessible anywhere and by any devices. Beyond that, it also provides capabilities to help you manage your pilots, drone fleet. Another thing that's unique about SiteScan is it's designed for collaboration within the drone teams for many users. Next up is ArcGIS Reality Studio. It is our solution for large area aerial surveys. It is designed for citywide and countrywide mapping, and it's optimized for working with multi-head metric cameras, which are used in the surveying aircrafts. This lets us achieve survey-grade accuracy even for projects covering very large areas. We have recently added support for a local distributed processing, which means that you can achieve much greater efficiency by sharing the processing load across different and multiple computers running Reality Studio on the same network. ArcGIS Reality for ArcGIS Pro is our reality mapping extension for ArcGIS Pro. It adds 3D reality mapping to ArcGIS Pro, supported by drone, aerial, and satellite imagery, all of them. Bringing reality mapping into ArcGIS Pro, it helps us automate production workflows by just tapping onto the large suite of photogrammetry or the geoprocessing tools that are available in ArcGIS Pro. I am sure many people might have come across and used geoprocessing tools. We can use all those tools on the outputs of Reality for Pro and further facilitating data integration. So with comprehensive understanding of ArcGIS Reality product family and its specialized tools, we are ready to explore how these components integrate into seamless photogrammetric workflow. In this next section, we'll walk you through a step-by-step demonstration showcasing how to capture, process, and analyze spatial data using ArcGIS Reality. There will be a hands-on demo to illustrate the practical applications and efficiencies that these tools can bring to your project. So how does ArcGIS Reality work? The ArcGIS Reality processing workflow begins with the input data, importing overlapping images with location and orientation information. Optionally, you can also import results from third-party aero triangulation like Match AT. But if you aren't using a third-party AT solution, the second step is to perform alignment to refine the orientation of image. This is referred to as aerial triangulation or bundle block adjustment. The last step is producing output products through reconstruction. For optimal results, it is recommended that you use nadir images for 2D outputs and using nadir and oblique images for 3D outputs. So now let's shift to the hands-on demo. So this is our site scan in web browser. We here have different projects which are created on the left. These missions can be created, planned along with the drone flight path and outputs on ArcGIS Flight app. Or we can just upload our drone images after creating a new project here. When we open these projects, we have different projects here, and I'll be showcasing for demonstration purposes. I'll be showcasing a mining demo. When I open this project, I have different missions created here. I have opened the survey because I have already uploaded the photos for demo purposes. After this, on the left, we can see a contents pane. When I click on the photo, I can see all the images and their footprint. And when I click on any circle, I can see actual image captured by drone, the corresponding image on the ground. Then on the left, we have ground control points, which can be automatically detected here if we have created a mission using ArcGIS Flight app, or if I wanted to, I can manually tag my GCPs. After that, we have the feature of mission area. Mission area is feature that constrains the extent of a processed output. For example, if you don't want to process the whole flight plan of your drone, and if you want to process a small area, you can just edit the geometry of the mission area and we can enable this mission area checkbox in the processing menu to use this capability. On the bottom of this contents pane, we can see a ribbon where we can manage mission, process or reprocess the mission, export and share the mission to ArcGIS Online Enterprise. And when we try to process this, as I have already processed the mission, it will say confirm reprocessing. So after we are satisfied with all the images, we then process it. And this processing pane, we can adjust output quality, mission area, and if we want to generate a 3D product, 3D mesh or not. Satisfied with all these inputs, we then process the mission. After we are done, we also receive an email along with the processing details. Processing and all, it will be happening in the cloud. After all that, we get this beautiful true ortho. Nice thing about true ortho is that every pixel here is in its accurate 2D location, and also along with 2D, also along with true orthos, we have our elevation data. Elevation data, we have contour, elevation model, cut and fill analysis. This allows you to quickly compare the change in elevation and areas and volumes from one data set to another, or with a comparison design surface. And here it is taken as the level plane. Here it has automatically detected the elevation of the level plane. When we go onto the measurements tab, here I have already created a small polygon over mine waste dumps. But when we click on this drop-down menu, we get to know the net volume, the cut, the fill, and the total area. Further, if we want to view and compare this volume in 3D, we can do that. And if you want to see the volume report, comparing it to the other data sets, we can also do that. So when we compare this to the true ortho on the right, we can actually see how easy it can to calculate the volume of the dumps here, of the mine waste dumps here. So this is the actual beauty of side scan. Now, coming on to the 2D rest of the 2D products, we have our hill shade, which is the basically the grayscale 3D representation of the terrain surface with sun's relative position taken into account. And then at last, we have our visibly atmospherically resistant index, which is designed to emphasize vegetation in the visible portion of the spectrum. Now we take a look at our 3D products, which is the 3D mesh. It could take some time to load, but this look at this beautiful 3D mesh created. We could also do some analysis in the side scan itself. I can create a polyline in the same way as the 2D, and then I can also get the elevation profile along with the slope in degrees and percent. So this was all about site scan. I hope you all liked these advanced tools. But I would like to remind you that it is a SaaS-based offering and you can upload the data from the field itself. And by the time you get to home from office or vice versa, your output will be ready. Then this output can be shared to your ArcGIS Online or Enterprise for then further analysis. So moving on to Reality for Pro, we have this imagery tab inside the ArcGIS Reality for Pro. So this is an extension, and when we open the ArcGIS Pro normally in this under the ribbon imagery tab, we have this creation of new workspace. When we click on the create new reality mapping workspace, we can name our we can give a name. After giving the name, we are provided with a drop down menu of drone, satellite, or aerial images. So whatever we discuss like side scan for drone, this is basically a further set of everything where we can process every type of data here. So once we are done with creating a new reality mapping workspace, we get this image collection, which contains the boundary of the images, footprint of the images, and the images. Here I have used a stereo images from Pleiades new satellite. So after that, we do the bundle block adjustment, and after bundle block adjustment, we are given the true orthos in different products, 2D products. So this is the beautiful true ortho which has been generated. And along with that, we also have this TSM which has been created. So also we have these solution points, GCPs, checkpoints, tie points, which support the processing of the which support the reality processing. Moving on to this 3D scene, that we have the mesh, the same 3D product which has been created of the same using the same imagery in the workspace. The beauty of this thing is that we can also publish this data to ArcGIS online. And as you can see here, that this is the published data which I am viewing directly from the internet. You don't you don't need to use ArcGIS Reality for ArcGIS Pro here. Once you are done with publishing, you can share it across your organizations and other people can just view what you've done in what all hard work that you've done. So getting back to my presentation, so at last we have this applications of ArcGIS Reality use cases across ArcGIS ecosystem. Having walked through the detailed workflow and demonstration of few ArcGIS Reality family members, let's now explore its real-world applications. Reality mapping content brings GIS data to life. Here we are starting with a true ortho overlaid with cadastral data shown through the color coding on different buildings. This is already an intuitive way to visualize this cadastral data. But the same when viewed in 3D, it gets more immersive and it makes our experience more immersive, making it easier for user to identify buildings. We can just click on them to display their attributes. Further, here we see 3D mesh of an air control tower. It is essentially a visual database. Someone can click anywhere on this model and then see the corresponding image. And this helps inspectors finding flaws in the buildings, or you can relate to your own work domain. Reality mapping also helps us organizations manage the life cycle of their assets. It provides highly accurate and up-to-date foundation for engineering, design, and urban planning. Further, seamlessly integrated with BIM models. Like in this example, we are using ArcGIS GeoBIM with ArcGIS Online. You can edit out a section of the mesh in ArcGIS Pro, and then simultaneously you can replace it with a BIM model. In this webinar, we explored the powerful capabilities of ArcGIS Reality. And to be honest, in summary, it is a product suite that lets you perform reality mapping using ArcGIS. I just want you to remember one thing, that no matter what product you use, be it the Elder Site Scan or Younger Reality Studio. All of them are powered by the same ArcGIS Reality engine. So that was all about ArcGIS Reality, and as the tagline of the family says, so it actually does, which is delivering pixel accurate results and powered by the Reality engine. Now we'd like to open the floor for Q&A session. Feel free to ask any questions you might have about the topics we've covered, and we'll do our best to provide any insightful answers.